All right, ladies and gentlemen, welcome back to 777 Television, your home for everything Matrix encryption. And I'm your host, Watson Williams. Thank you for joining us. Today is December 19th, 2025. It's early in the morning. And in today's video, we're going to be encrypting a file that contains an entire book. We're going to do this with a software program. It is compiled and it runs on desktop. I personally wrote this, and the core of this program, this cryptographic program, is under active patent with the United States Patent and Trademark Office, USPTO. And so we're going to be encrypting some data today. Again, this is file data as opposed to plain text. Now, the program I wrote handles both, but it's a little more impressive, I feel, to show that we can encrypt files, and not only file data, but entire books worth of data, just to show you the capabilities and to demonstrate how fun and easy it can be to encrypt your own data. Now, there are a lot of things that we could say from here about what we're going to be doing, but let's forego all of that for now, shall we, and get straight into the demonstration. Okay, welcome to the demonstration. I pre-recorded this, and I'm just going to do a little narrating. You're going to hear Mario 64 playing in the background. I hope that's okay. Here we are just opening the file that contains the compiled programs, and we waste no time in opening the file that we're going to be encrypting. This is A Christmas Carol by Charles Dickens, and we're lucky enough that in this case the PDF contains bookmarks, and so you can actually navigate anywhere in the book. And when we encrypt and decrypt, all of this data will be preserved. We show a few of the illustrations in the book. I believe A Christmas Carol was first published in 1843, so it's pretty old. It's a very classic book, and considering the time of year, I thought that it would be an appropriate choice. And this book is, what was it, 93 pages. The whole book. Okay, now let's launch our programs that are actually going to do the encrypting and decrypting. The one that we place on the left-hand side is our encryption function. The one here in red on the right is the decryption program. We open our supplemental text files here. These are our file codecs. This encodes the data and turns it into a big integer. Then you have what we call the master key. This is an integer key that is added to the data, but prior to adding the key, we're actually going to shuffle the data at the byte level. And so we enter the name of the file, which is Christmas_carol.pdf. We then enter the name of our file codecs that we're going to be using, fractal file codecs. Would you like to activate holographic character mapping? This is a non-deterministic defense layer, and so we're going to activate a single holographic pair that is chosen at random, matched a 3-digit number with with one of the byte strings in the file that was uploaded, and we ended up with 14,358 holographic digits to add to a file that's already just under a megabyte. And so, as you can see, when we go to shuffle the data, we need a key that's over 1 million rows long, not million digits, but rows. So see, the shuffle key is each placement in a shuffled order. It's like shuffling a deck of cards. And so we're going to upload the Seraphim shuffle key because it's plenty long enough. The Seraphim shuffle key has 2 million rows, whereas we only needed 1 million rows. And so the integer key we need is over 3 million digits, and our master key is exactly 6 million digits. And so when we upload it, it's going to be tapered and otherwise trimmed down to size. A similar process happens with the shuffle key, where all of the entries, all the order placements that are larger than needed, they're all separated out. And so we have automatic tapering of keys, and the master key is being added to the shuffled HCM injected encoding of the book data. And so the encryption's done. We're just going to save to a file just by convention. We're going to name it similarly so that they'll sort right side by side in the folder. And so there it is, Christmas Carol E. And this is the sort of power that matrix encryption gives you. This is what we offer, the ability for you to personally handle this sort of power. Feast your eyes on an encrypted book that's over 3 million digits. This is a digital integer cloud in a superposition of meaning where so many possibilities abound that you could reconstruct practically anything, coherent or otherwise. You would never know the difference. You can reconstruct the wrong file type because there's just so many possibilities. That's how strong matrix encryption really is. We'll talk progressively about this in additional subsequent videos. We've talked about it a bit before, but we haven't really articulated it to our full satisfaction. But so here we are entering the name of the encrypted file, Christmas Carol E for encryption obviously, and odd number of digits detected. There's no problem there. That's just something esoteric, nothing to worry about. We enter the name of the key file, Seraphim master key. Again, this is symmetric encryption, symmetric cryptography requiring the same keys, but in our case we use a key set. It's a triple key system now. We have evolved. We used to only use 2 keys. Now we added the shuffle key being the third. And this just takes a few moments. Doesn't take anywhere near as long as it used to. We've really improved the efficiency of this program and how it works. Does the data require unshuffling? It sure does. If you don't unshuffle it, or if you unshuffle with the wrong shuffle key, you're not going to get the data back. We don't demonstrate that in this demonstration, but we can easily do so. It's entirely true. This is par for the course, and we have uploaded the shuffle key. Remember, we are unshuffling over 1 million rows at the byte level. The data was put back in order so that it could be not just deciphered, but the file type interpreted. If you quickly noticed just then, the file type was identified as a PDF, and so there is no need for the recipient of encrypted data to know what the file type is, because assuming you use the correct key set, the data will be correctly interpreted and the file type out of currently 13 different file types will be automatically recognized. That concludes this demonstration. I really hope you enjoyed it, and we'll see you in the next video. Thank you.